Okay. I think everything is like it's supposed to be. Let's see. Seems right. Okay. Welcome on in, everybody. Here we go. Let me get some of this roll taken right now, and then I'll ask later because it's important. So let's see. Tuesday, we got. If you're just on the YouTube stream and not on Zoom, if you could throw your first name and the first letter, your last name into chat so I can verify, basically so I can take roll. Okay, so I'll try this again in a little bit, but looks like we got it largely taken care of. So if I'm calling out a name, it means I have you marked as absent. So many of you are here and I got your names, but if you hear your name, you're marked as absent, so let me know. Michelle, with two last names, hyphenated M and C. Elizabeth N. I think those people are getting dropped. Let's see. Haven't shown up yet. Okay. Juan, R, M, two last names, an R and an M, named Juan. Juan, are you here? Ismail T. Anthony Z. Christina Z. Okay, that's not seeing any responses, so I think those people aren't here. Yeah. So and you can start off on the YouTube stream if you want. Some people do that. They just throw their name in the chat and then I can get them that way. So whatever works for you. Okay. But I got you, April. You're good. So you can switch over to whatever version you want. Zoom, YouTube, whatever works for you. Okay. So where are we? Oops, that's not my list. Where did my list go? I had outlined some stuff and now I put my outline somewhere that I don't see. Anyways, okay, I think I know where we're at because I just made the list, so I kind of remember what I put on it. So, couple things. So, really important that I take roll. This is the week that I have to do drops. So, sometime between Thursday and Sunday, I'll be doing those drops. So, there's two things that I have to look at contractually to do these drops. Like, I'm not a big fan of dropping people from classes, but I have to do this. So, two things that I'm supposed to look at: attendance and participation in the class. So kind of two questions that need to be answered if you want to stay in the class. Have you been attending class? Yes. Have you been participating? Yes. Then you're good. If the answer is no to one of those, then you're starting to get into bad territory. If the answer is no to both, you're definitely getting dropped. If you haven't attended the classes, then you're definitely getting dropped. And then there's kind of a spectrum for the homework. Some of you have done a few homeworks, which is great. Some of you have done no homeworks, which isn't great. So on Thursday, when I pull up my roll, if you haven't done any work, that is, you've made zero progress in the class, then it's pretty hard for me to make the argument that I shouldn't drop you based on progress, right? I mean, I have to think about, like, okay, if this comes up later and the administration's like, why didn't you drop this student? Oh, well, I don't know. I just didn't want to drop them. Like, that's not going to work. I have to drop people who are not participating in the course. So make sure that you have some homework scores by Thursday. Okay, Thursday is, I don't know if I'll do it Thursday or which day I'll do it, but I potentially could do the drops Thursday. So I have to see evidence of progress by then, that you're progressing, that you're participating, that you're probably, willing to do the work to pass the class. If not, I gotta drop you. So, like I say, I would say it's about half of you are about 4 assignments in, which is great. About half of you are 0 assignments in, which is bad. So make sure you're hitting those up and getting those things taken care of. First of all, because the assignments are due kind of soon now. Like, it's not super far away, and you're kind of getting to the point where you're going to have about an assignment a day. It's nice to have less than an assignment a day to do. So remember, you can work on assignments late, but it's for 50% credit, so that's not great. You don't want to be getting 50% credit on stuff. You want, realistically, those homework grades can be up in the 90s and hundreds. I see a lot of students that just get 100 on the Delta math assignments. That's really good. That's obviously going to help your grade. Getting low homework scores is going to hurt. What you generally want in a math class is to have a high homework grade, because that's going to pull up your test grade, which sometimes comes in a little lower than people want it to. So you want to make sure you have that nice homework grade that's going to help pull you up into that successful category, whether that's, whatever it is. You all have different goals. Some of you want an A in the class. Some of you want a C. Either way, sometimes those test scores come in a little lower than you'd like, and that homework can help pad that, okay? So make sure you're getting that done. It's due soon. I did change things around a little bit if you're looking. I went by sort of the course outline that we're all supposed to follow as teachers, and that's what I originally set the course up as, because as I mentioned, this is my first time teaching this particular course. But I've realized I didn't like the order that they had some stuff in, so I've reordered a couple things, and I extended some assignments. So, because really you want to have a handle on the factoring before you do rational expressions and rational equations. Some of you have done those parts. I see some people got 100 on those sections. Great, you don't have to worry about it. Some of you still have to do it. So I changed the due dates a little bit, changed the ordering of these things, and you can, you should be working through those. Those of you who are like halfway through the assignments, that's great. You don't have to rush. You still have plenty of time to kind of take it easy and still get everything done in time. If you haven't done anything, now is the time to like get moving, or you're gonna end up with some late penalties, and those aren't good, especially at the beginning of the semester. So try to take care of that. Okay. And as far as I know, everyone's able to. I haven't heard any complaints about homework. Oh, there's a couple things about like using the homework, but as far as I know, everyone's able to get in there, set it up, and use the homework. See the due. Remember, the due dates are in there, so you can see when all that kind of stuff is due. So I figure what we're going to do today, a large part of what we're going to do today, is go over some sample problems. I know that the meeting we had last week wasn't great. The power was off at my house, so I had to go into my office where the equipment is barely usable just for like day-to-day stuff, let alone for trying to like stream a class and teach a class. It was terrible. So some of the stuff we go over today will sound familiar if you were at that meeting, but we're able to do it in a better way this time. Okay, better explanation. You can see the stuff. So if you're on the YouTube stream, you'll actually see the stuff that I'm talking about behind me. Whereas if you're on the Zoom stream, you won't see the visuals as much. Okay, so whichever you want to be in, whichever stream you want to be in, but it's going to be helpful to see the visuals from YouTube. Okay, so just start at the top, right? Work your way down to the bottom. Still getting the homework squared away. I'm in touch, still trying to sort of wrap up that mess. I'm in touch with I have an appointment set for next Monday with the publisher, and they're just going to I have a 30-minute appointment with them, and they're just going to help me get everything squared away so that it's all right after the mix up with the bookstore, and I can make sure that their mix up, I should say, at the bookstore, and then I can make sure everyone's got what they need, and it's easy for you to all purchase the license and that kind of stuff. So should have that information out to you next week. I did put up oops, let me change this setting. And then did someone just come in? Remember, if you're coming in after I took roll, let me know you're here. Just in chat, say that you're here or something, and then I can mark you down. So I have accurate roll from which I'm using to drop people. So we're not there yet, but the next chapter is systems of equations. I guess we should go ahead and publish this. I think everything's set up in there, right? Yeah. Yeah, you've got your stuff that you need. I'll go ahead and publish that. Some of you are going to be close to being ready to start the systems of equations section, and I put up some assignments for the systems of equations chapter. So, when you get to the point where you feel like you have chapter 1 behind you, feel free to start chapter 2. We'll be discussing some of it and going over some of it. But there's no reason you can't get started on your own. Some of you like to do that. Some of you want to sort of wait a bit. That's fine. Whatever works. Oh, one thing I wanted to mention. So at the beginning of the semester, this class was supposed to be on ground, right? Yep. We were supposed to meet in the science building 2:30. This one was supposed to be on ground, and then they announced to us that everything was going online for 2 weeks. But even then, at that point, at the very beginning of the semester, they said, we're probably going to extend that into February. Like, they kind of knew, but they wanted time to make sure they knew what was going on, watch the science and see what's going on with COVID and stuff, and then decide whether to expand that or not. But they were pretty sure they were going to end up expanding it into February. You should have all received an email informing you of the school's decision to now extend things again until mid-February. So I think it was in this class we talked about it too, where they kind of suspected they were going to extend it past that first 2 weeks. So we kind of knew that was coming, and it did come to pass. By that same reasoning, they do not expect to extend it again, right? The COVID numbers seem to have peaked and are coming down again. The Omicron numbers seem to be coming down again. Not hospitalizations, because hospitalizations follow by a couple weeks, so you're still going to see a lot of hospitalizations, but the number of cases seems to be coming back down, which means whatever it is, 2.5, I guess, almost 3 weeks. Almost 3 weeks that we have till we're going to be back in the classroom. The numbers are expected to go back down significantly. So the bottom line is, this time when they say, I think it's the 14th they said, and we don't have class on Monday, so I think that means for us our first class is likely to be February 15th. They actually think this time that we are in fact going to be back in the classroom. So no one's really expecting that they're going to extend this again. Who knows? They could, but both the education side that wants to get people back in the classroom and also the science side says the cases are coming back down again. We likely will be in the classroom in a couple weeks. So if you are someone who has not prepared to be on campus, start that process now. Make sure you're taking care of that. This is an on-ground class. You cannot be in this class if you can't go on campus. Okay, I've had some students already saying, well, can't you do both? Can't you do the online and the on ground? And the answer is no. I don't really have a good way of streaming our meetings if I'm there in the classroom. And then also, that's twice as much work. Why should I do that if this was agreed that it was going to be an on-ground class? So if you are in this class and you're planning to take this class, then you have to be willing to show up to the classroom. in order to be on campus, you have to get your vaccination, and you have to upload your vaccination card to the VCCCD app, the school app, the web portal for the school. You have to upload that. I highly encourage you not to wait till the last minute, or you're going to end up missing a day of class probably. Just get it taken care of now. If you're going to get your shot, get it now. If you haven't already, upload your card, your vaccine card to the school. They'll okay it, and you're all good to go, and you won't have to avoid any kind of big rush that we are sort of likely to see on day one back there. Please be aware the COVID, I'll go over this again, but the COVID protocols that we were supposed to follow are not up to the teacher to decide. The protocols are the protocols, and we are to follow those. I believe in them, but also it's not my choice anyway, so it doesn't really matter what my opinion is. Have to follow them. I'm not allowed in the classroom if I don't have my bracelet. You are not allowed in your classroom if you don't have your bracelet. So you have to get checked out. That means making sure everything's prepared now. If you tell me when we're going back, I can't come to class because I didn't get my stuff taken care of, that's not really like a reason to extend stuff for you because you sort of didn't take care of it. So please make sure that you're ready to come back when we come back. Okay, so there's that. And then was there something else? Nope, I think the rest of it was pretty much the homework and stuff. So I have some problems that I'll go over today. Excuse me. I kind of showed you stuff last time, but I know it was really it was hard for me to present stuff on the Zoom whiteboard feature, especially since my pen, I'd left the pen at home, and it turns out it was dead anyway, so I probably couldn't have used it anyways. Trying to draw with my finger is not the greatest lecture. So if you still have questions, that's fine. You're always welcome to send me questions. Send me either a screenshot of the problem or send me the specific title of that problem. This is Systems of Equations, Graphically Level 2, something like that. Then I know exactly what you want to talk about, and we go over it. I'm kind of hoping if everything goes like I'm expecting it to, we can kind of save off. Well, we'll have to see. Probably, I don't know. We'll see. We'll see how things move. But we're going to spend a little bit of time in here in this chapter 1, or this first grouping, this first module of problems, because this factoring is a big topic. I know it's just one thing, but there's quite a bit more to it. It's like a whole chapter in the algebra book. And good, someone's asking a question. I'm confused on this one. Graphing piecewise functions level 1. Great, because that's actually what I was going to talk about. So I'm really glad to see that some people still have that question, because we're going to talk about it today. That's one of the things we're going to look at. So great comment. That sort of helps clue me in that I'm going over the right stuff that you need to see. Because remember, it's just not possible for me to cover everything that I need to cover for this class. So in the meeting, where right now we're meeting 90 minutes a week, I can't cover everything. So that's good to know which things are that people have questions on, or most important to show you, because you have questions on them. So we're going to go over some of these today, and if there's more questions, feel free to let me know. But I definitely know people struggle with functions a little bit. Like evaluating simple functions is, people get it. Okay, so I take the -1, that's my x. I plug it in here and I simplify. It's pretty straightforward. So if I plug -1 in here, I get what? 2 times -1 is -2. -1 is -3. So the -1 is my x value. The -3 is my y value. I submit that. I get the green check. Literally, that's all you did, is you substituted -1 in here for x, and you simplify. Most people get that, and they get comfortable with it. Whoops, let me move my window. There we go, so I can scroll better. Okay, so that's that part of the functions people are pretty good with. Let's go back. Evaluate functions level 2. This is just stuff where they start putting in exponents and stuff. The main thing here, make sure you follow your order of operations, right? You have a squaring function and you have a multiplication function. So which is the one that you're going to use? Well, order of operations says you do exponents first. I see people a lot of times do the multiplication first. Got to do exponents first. That's the order of operations. So just know that. Okay. Piecewise functions. Let's kind of put some of this together and make sense of it, because I know some people are still having questions with it. So evaluate piecewise functions graphically, and then evaluate piecewise functions like algebraically. So what is a piecewise function? Let's take a look here. Desmos. Okay, so a piecewise function, you can think of it as just kind of like a Frankenstein function, right? It's a bunch of different functions that have been kind of chopped out from some other function, and then we're just kind of smashing them together. Sometimes they're going to line up really nicely and look really good. Sometimes they're going to be all like messy looking and jagged, and the lines and curves don't line up nicely at all. Totally fine. It's still a piecewise function. So that's how you want to think of it. We're just taking pieces of other functions and we're sticking them together to make a new function, right? So why would we need a piecewise function? Why might we do something like that? Well, it's just a scenario where you have different rules for different values. Like we're used to, you know, this function notation where we've got we've got a function, say f of x equals 5x minus 3, and there's one rule, 5x minus 3. So no matter what you want to do with that function, the rule always says multiply by 5 and then subtract 3. That's the rule every single time you use this function. Well, some functions have more than one rule that needs to be followed depending on the x value that corresponds to that function. So what would be an example of that? Well, sometimes maybe you have a business and your business has to buy parts, and the supplier that you buy your parts from might charge differently depending on the number of units that you buy. So we might have y equals, our unit will be cents. So we'll say 10 cents, but it's not always 10 cents. The price is 10 cents per unit, but only when 0 is less than x is less than, say, 10. So see how we have a line here, but see how it stops? It doesn't go on forever like we're kind of used to drawing our lines. That's because this line only represents the x values from 0 to 10. So this would say maybe I have a pricing where if people buy 0, maybe I make bike frames for, and then I sell those bike frames to companies who want to assemble the things. Well, if you buy between 0 and 10 bike frames, then the cost is, let's make it dollars. The cost will be $10 per bike frame, okay? But what if you buy more than that? Like companies like that when you buy larger amounts of things. So sometimes they give you a better deal. To say, well, y equals 8 if 10 is less than x is less than 20. So now, if we want to look up the price, well, what if I buy 12 bike frames? Okay, that's right here. My x value is right here. My y value is up here. It's now 8. I'm getting a better deal. I'm getting a better deal. And so, oh, that's good. And then they go, well, we really want you to buy a lot of bike frames, so we'll give them to you for $6 a piece if you're willing to buy 20 or more. So then you get this price. So see how these are really 3 different functions that we've chopped them up and smashed them together to form this new function? This is what we call a piecewise function. It has a different rule that you follow depending on the x value that you're inputting into the function. Okay, this graph gets inverted if you start talking about, like, if you're on the other end of things. If you're, say, an electricity bill or a water bill or something like that, those of you who have paid those kind of bills, there's usually tiers. So you've got like tier 1, which is like the first, the first 10,000 gallons you use of water in a month comes at a pretty cheap price. Then once you go over that, you jump up to the next tier, and everything over 10,000 gallons now costs you quite a bit more. And then like how it is in Ventura, if you go into tier 3, you're paying a lot of money per gallon, right? So they're just paying you for that, you're just paying the higher price on those gallons that are over the cutoff, but you're paying quite a bit more, right? So, you know, this would kind of be inverted, but again, we could use this piecewise function to describe to us the behavior of the overall pricing for whatever it is that we're looking at, okay? Oh, it's going to log me out. I better extend this. Where am I? Oh, here we are. Okay, so piecewise functions, you've just got things crammed together, and they don't have to be lines. It could be, you know, this could be x squared for x less than or equal to 4, and then this could be square root of x when 4 less than x is less than 9, and then we've got, you know, negative x squared. Let's make this x minus 5 when x is greater than 9. Oops, and we have to kind of come out to see it. You can see here, this is not a very clean looking function or pretty looking function, but it's 3 separate functions that we've cut off and smashed together. That's what we're doing with a piecewise function. So this is graphically how these things would look. Now what you don't want to do is just have all 3 graphs completely graphed. So for instance, this is sometimes what I see. People will just graph all 3 pieces and say, there it is, there's my piecewise function, but this thing isn't even a function, right? This fails to pass the vertical line test. So if I scan this here, see how I'm hitting the graphs in more than one place at a time? Then that thing's not a function. So this should be an indication to you that something's wrong. But this is a lot of times what I see on a test when I have people graph a piecewise function, is they just graph each function. Well, remember, the next graph we said is only supposed to hold from what, 0 less than x less than 4. So we only draw the part that has x values between 0 and 4. And then for the second one, we say, well, we want that to exist from 4 to, what did I say, 6? So then that part of the graph, I don't remember what value I picked, but it only exists from x values of 4 to 6. And then this parabola here, let's just say in this case I want it to be x greater than 6. It should look like that. Now it passes that vertical line test, right? When we scan this, we never see it hitting the graph 2 places at once. So it's a function, okay? So that's what a piecewise function is. We've taken 3 separate functions. We've decided over which x values they exist, and we've just smashed them together. So that's what it looks like graphically. So then how do you read these things? So let's do, where are we? Evaluate piecewise functions. Actually, let's do evaluate functions from a graph first, and then we'll look at evaluate piecewise functions, because that's helpful too. Okay, so this says find the value of f of 4 when this is our function f. Okay, so what does that mean, f of 4? Well, remember we just talked about this algebraically. That 4 is the x value that you are feeding into the function f. Okay, the 4 is the x value that you are feeding into the function f. So then f of 4 is the y value. So the 4 is the x value, f of 4 is the y value. So when they say find the value of f of 4, what they're really saying is look at the graph and tell me the y value when the x value is 4. So you go, okay, well here's 4. Let's, it's not going to let me zoom in. No, it's not. Oops, that's not what I want to do. Here's 4. So I go up and say, oh, it looks like the y value is 3. See how for an x value of 4, here's our point, that has a y value of 3. So we say, okay, I think this is 3. Submit answer. And got it right. So see how they're doing it with these lines? They say, yep, you want an x value of 4. That indicates a y value of 3. Okay. We have something like this. F at -3. It looks like it's going to be -4. So we put that value in, -4. There's a specific problem I'm looking for here, is why I keep doing these. Maybe I'm thinking of another section. I thought it was going to give me something different here. Let's try one more. So that looks like it's 5. So f of -5, the x value is -5, so we find -5 on the x-axis. We go up. Looks like the y value is 4. Let's try one more. No, okay. It doesn't have the type of problem I was looking for. It's not showing up. Or maybe I'm thinking of a different section. But that's just how you get, like, always ask yourself when you're looking at the graph, what are the x values and what are the y values? If you understand what are x's and what are y's in the graph that you're looking at, then the rest of it's straightforward, right? It's just figuring out the notation and understanding what they want you to do. So we're going to play the exact same games to evaluate a piecewise function graphically. The only difference is now we have this piecewise function, where in this case, I guess this is actually the problem I was thinking of. I was thinking they had that in the last section, but it's in this one. So here we have a graph, and what they've put, this circle here, the hollow circle, means we have a hole poked in it right here. And the actual function value is this filled in solid dot. So they want to know about f of -2. So that means our x value is -2. F of -2 means the y value. So they're asking, what is the y value when your x value is -2? Well, we go to -2 and say, well, that would be this line right here. And at -2, my y value looks like it's -5. We have this dot right down here. So I'm going to go -5. Right, see how they do it right at -2? At the x value of -2, our point is at -5, and I got the answer correct. Okay, so let's look at another one. Evaluate the function graphically. Ooh, so here's a more complicated piecewise function. Looks like we have something, probably a parabola, piece of a parabola right there, and then also the line. Okay, so what do they, like, I'm seeing my, okay, here's my 2 pieces of my graph. What do they want to know? F of -8. Okay, so that means I'm looking at -8 on the x-axis. I find my graph. That appears to be right here. Looks like a y value of -4. So from -8 we go down. Y value of -4. Put it in here. And we got that. Okay, let's try another one. Evaluate the function graphically. So this is just another one where there's a hole. In this case, we do f of 3. Oh, here's my function value. It looks like it's -5. There's one I'm trying to get it to give me a certain type of problem here. So let's see. F of 1, so we find 1 on the x-axis. Our function value is down here. That should give us -6. Okay. Let's see. Will it give me the one I want? This isn't the one. Oh, this one works, though. This is another thing we haven't talked about yet. So f of 9. So that's an x value of 9. We want to know the y value when there's an x value of 9. Okay, well, that would be right here. Well, wait a minute. I don't even see a function over here. Right, our function doesn't exist for an x value of 9. And remember, when something doesn't exist or make sense in mathematics, a lot of times we call it undefined. It means it hasn't been defined by anything. It's just like some weird, meaningless thing. So in this case, we would say undefined. They have an undefined button that types undefined for you. Or, you know, if you're someone who doesn't like to use the mouse so you can move faster, you can just write undefined. You can type it out, right? Either way. Just spell it right, or it's not going to like what you do. But we're undefined over here because our function doesn't exist. The function is not defined at x equals 9. It is undefined at x equals 9. Okay? And you have that button. I'm getting not a lot, but I'm getting a few questions from students who are having trouble answering like how to input the problems, and that's fine. Feel free to ask me those. But usually they give you kind of an indication as to like what it is that they want, right? So like here, if you see a button for undefined, that doesn't mean the answer is undefined. We go, oh, that's how I do the undefined part, right? Usually there's some kind of indication. On the delta math, sometimes you're going to have problems that have more than one solution, right? So for example, a quadratic equation is generally going to have two solutions when you solve it. You separate those solutions with a comma. Okay, so it's like 2, 1 is how you would put those in there, and then it'll take your answers, okay? Okay, so we got evaluate piecewise functions graphically, and if there's questions while I'm doing this, feel free to throw it into chat, or if you're in Zoom, you can raise your hand for the raise hand feature under participants, and then I can answer your question, however you want to do that. Okay, so let's see. Now let's evaluate piecewise functions algebraically. And I know students struggle with this one too because they get confused. We just looked at piecewise functions graphically, but now we are looking at an algebraic form of the piecewise function. It's just how we write these things down without drawing the picture of it, right? So just like you can write the, for a regular old line, we can have things that are y equals 2/3 x minus 1. We have both the algebraic way of writing the equation, and then we have the graph, the picture of the line itself. We have both things. So we just looked at the image of piecewise functions, but now we want to know how to read them when they're in this non-graphical form. They're in the algebra form. So I'm looking at these three. It looks like this piecewise function is constructed from 3 different rules. There's 3 rules that go into making this thing. So how do I read this? The thing on the left is the rule. It tells you how to calculate your y value, and the thing on the right tells you when to use that rule. So this is saying if I have an x value where x is smaller than 3, then I use this top rule right here. If my x value is equal to 3, then I use this rule right here. And if my x value is bigger than 3, then I use this rule right here. Okay, let's take a look at what that looks like graphically. Let me pull this out so I can kind of do both at the same time. Just so you kind of get a sense, right? Because you want to understand the graphical representation and the algebraic representation. So this rule, that should be it's a second-degree polynomial. That should be a parabola. This one should be a horizontal line, and this one should be a slanted line. So let's see what that looks like. We've got negative x minus 2 squared minus 3. Also, I would encourage you to use Desmos. Getting in there and playing around with some of this stuff can help you make sense of some of the graphical stuff. Don't do it as a way to just get you through your homework without understanding what you're doing, because then you're going to be hurting yourself. But if you use Desmos as a learning aid to help you learn what you're doing, you could very well end up understanding more because you played around with it a little bit in Desmos. So let's see, this is going to be for x less than 3. Then we've got negative 2 for x equals 3. I don't think it graphed that one. I don't think it's going to be able to graph a point. So let me do it as a line that's really a point. I think it's getting confused. So this is really 3 comma negative 2. And then we've got y equals 5x minus 21. And that's when x is greater than 3. Okay, so here's what this looks. So here's the problem written out in algebra form, here's what it looks like on the graph. So we have our parabola part that goes from, x values that are less than 3. So here's 3 right here. So to the left of that, it acts like the top rule. It looks like the parabola. Right at 3, we have the value 3, -2. Right? That's what we're given right here. When x is 3, the y value is -2. That means the point 3, -2. And then to the right, we have 5x minus 21. So that's the black line right there. Those 3 pieces together give us our function. Okay, it's a piecewise function. Here's what it looks like graphically, kind of an ugly thing. It's not really, like sometimes your piecewise functions will match up and they connect and it looks really neat. Sometimes they just kind of look like junk like this. Okay? So then how am I supposed to evaluate that? Well, they want us to find f of 1. So remember, what does that mean? That means our x value is 1. So we want to know that under this function, what is the y value when the x value is 1? Well, let's see. If x is 1, then which of these 3 does x equal to 1 fall into? Is 1 less than 3? Is it equal to 3? Or is it greater than 3? Well, 1 is less than 3. So since our 1 is less than 3, that means I should be using this rule over here. Okay, so I should stick my 1 in here and evaluate it. So 1 minus 2 is -1. Squared is +1. Then we have a negative on front, so that gets me back to -1. -1 minus 3 is -4. So what I did was I took my x value of 1, realized that this is the rule that matches it, or this is the condition that matches what we're looking at. So I use this rule at the top. I evaluated by plugging 1 into this at the top. Hit submit. Yes. And there it goes. So see how it's saying 1 is here, 1 is less than 3. So we use this one, substitute in here, and you're good to go. Let's try another one. Okay, so here's another one. Okay, so we want to find f of 5. So where is 5? Is 5 less than 2, equal to 2, or greater than 2? Well, 5 is greater than 2. So that's telling me that I should be using the one at the bottom. The -x plus 3, that one at the bottom, I should be using this one because 5 is greater than 2, so it meets this condition. Then we come over here, and -5 plus 3 would be -2. And we get our answer. Right? See how they're kind of like 5, -2. Here's the point. That's at -2. So they're showing you how to look at it graphically, which is one way to do it. But then also they're showing you how to do it algebraically. You want to do both, right? Both of these are easy enough to grasp, but you should really be able to do both. You want to be able to graph it. You want to be able to do it algebraically. Okay? Let's see what the next one looks like. Kind of the same, right? So this one's kind of interesting. Before we had it broken up so that all of our graphs together go from -infinity to +infinity. This time it starts at 0. Sometimes things can take on negative values. Sometimes they cannot, right? So for instance, your bank account, depending on the rules under which your bank account offers, sometimes your bank account can go negative, right? It is possible for you to have a bank account that has -$300 in there. Maybe you accidentally spent some money that you didn't have, and then there were overdraft charges on top of that. And so all of a sudden, you spent $5 that wasn't in your bank account, and then all of a sudden now you owe the bank $80, which kind of sucks. But in that case, it makes sense to have a negative value for a function, right? Sometimes it doesn't make sense to have negative values for a function, like a dosage. You're not going to add a negative amount of medication to a shot that you're giving a patient, right? Because what does that mean? I'm supposed to be putting stuff in there. How can I put in -5 milliliters of a drug if what does that mean, right? So it generally doesn't make sense in that, at least my understanding of medications, doesn't make sense to do that, right? So in this case, we're starting at 0 and we're just moving to the right. So this first rule takes place from 0 to 5. The next rule happens right at 5. And then after that, it's bigger than 5. So what would happen if they asked us f of -2 here? Well, then the answer would be that it's undefined because our function is not defined for negative values. So that's a thing to be aware of, especially when you're trying to use math in the real world, is asking yourself, like, do negative numbers make sense for this particular problem? Because it's not that negative numbers make sense or don't make sense. It's whether they make sense for the context of the problem that you're working on. So for you know, like I mentioned earlier, negative numbers can make sense. Usually if you're tracking time, you usually start at some time 0 and then you move to the right from there. But you could go backwards in time and say, oh, I actually want to know about yesterday. And then, you know, so it depends on what you're doing, whether that context makes sense. Okay? But is there any more questions on like this one? Does everyone understand how we would do this problem right here? Is that clear to everybody? Or do we need to see more of it? Yeah? Okay. Then if I'm not seeing anything, in the absence of questions or comments, I assume people are learning. So if I'm moving fast or you need to see something again, please do not be afraid to say, wait a minute, I'm not sure if I understood that. Can we spend some more time on it? Okay. Okay, let's see. Evaluate piecewise functions, graphing piecewise functions level 1. Okay, so now you're actually going to get into graphing them. So we're going to graph a piecewise function. So graph the following function on the axes provided. This is another case where, and it's okay, I don't mind answering them, but it's just that you'll save yourself from some time from having to wait till you get back to me. They're usually going to tell you what you need to do in the problem. So like click and drag to make a line, click the line to delete it, click on an endpoint of a line to change it. Okay, so we have to figure out, remember back in algebra, you had your whole graph this line. You had to look at the slope. You had to look at the intercept and figure out where things were from there. So this is saying we have a piecewise function, one for the x values that are less than 1 and one for the x values that are bigger than 5. So don't try to do both pieces at once. Just take it one piece at a time. So, okay, what do I see when I'm looking at 3x minus 4? Okay, so thinking back to my y equals mx plus b, that means that my slope is 3 and my y-intercept is -4. Okay, so I go to -4 on the axis, and then my slope is 3. So I'm gonna click here. Oops, it didn't do it right at first. I start here at -4, and then I'm going to go up 3 over 1 because that's my slope. And let's see. Let me see now. They actually want to know for x less than 1. So that means we're going to keep going this direction. Like that. And then you have to figure out what kind of endpoints do we have. Okay, so this says if it's all x values less than 1, it's going forever in the left direction, right, off to the left. So that means I want an arrow over here. So I'm going to click this until I get the arrow. Good, I got the arrow. Weird, it's kind of a dot and an arrow. Hopefully it marks it right. And then what about over here on this side? Is that what we want as a solid dot? Well, this says for when x is less than 1, but our dot is at x equal to 1. Well, 1 is not less than 1, so 1 doesn't count. So that's where we want the hollow dot, is when it's, if this was a less than or equal to, then we would make it a solid dot. But since it's just less than, because 1 can be less than or equal to 1, right? That's true. But 1 cannot be less than 1. How could a number be less than itself? So this should be right. Let's see if I did that right. Uh-oh. It doesn't like, oh, because I didn't do the second half. See how easy it is to do? I'm sitting here focusing on. Sorry, something got caught on my foot there. I was focusing on this piece, and I forgot to do the second half of the problem. Okay, so I'm pretty sure got the first part right. Now let's go here. So what does this mean? I know sometimes people get confused when it's just a number 2. So when x is greater than 5, the y value is 2. That's what that means. For any x greater than 5, our y value is 2. That looks like a horizontal line. So we go to 5, and then we're going to be moving to the right. So at 5, we go here and to the right. And let's see, do I want a solid dot on the left or a hollow dot? Well, x has to be strictly greater than 5. There's no equality there. 5 can't be bigger than 5. So we want a hollow dot. And then it goes on forever to the right, so we want an arrow. Let's see if it likes that better. There we go. Got my green check. So just break it down into separate pieces. I see people do this all the time where they look at a whole problem and they get overwhelmed and they try to do the whole thing in their head. Don't do that. Break it down into little pieces and just take it one piece at a time. Okay? Okay, so there's a question here that is a good question. So I just have a general question about doing the homework. Let's say you put the right answer and it marks it wrong. Do we contact you about it to check? I've had that problem with WebAssign in a class prior to this one. Yeah, WebAssign's bad about that. My math lab is occasionally bad about that, but it's pretty rare. What I will say is one problem here and there for your homework isn't going to be a big deal. And Delta Math, I've actually seen, I haven't really seen that where it's doing straight up wrong answers. I have had students contact me and say, I'm putting in the right answer and it's marking me wrong. But what's happening is students are generally, when I respond to those emails, I'm helpful to them, so they help you out. But it's usually that the student is putting the answer in the wrong way, or they're doing part of the answer. So, like for instance, this isn't a good example because your graph's either going to be right or not right, but sometimes students are putting in a wrong thing. So let me see if I can find a good example of this. I don't. Okay, let's do this. So this has two answers. This equation right here has two answers, 1 and -1. So sometimes a student might do this, 1 and -1, and say, well, it's telling me I got the answer wrong, but I know the answers are 1 and -1. So what am I doing wrong? What's wrong is you're supposed to put a comma in there to separate them, and then sometimes it goes, oh, do you want to put two answers in here? You put 1 and -1. Also, you can do that over here. I don't know if some of you saw, I did that on accident earlier. I pressed this thinking it was like a resize plus and minus, but it wasn't. It gives you more places for options. So you can either get this extra box by putting a comma in here or by hitting this and it gives you the extra answer. Now my 1 and -1 are separated. And so even though I meant to put the same answer as I did last time, it's really that I had it formatted incorrectly last time. So, and the thing is, you don't ever lose your chance to get your points here. So if you put it in an answer and then it's like, oh, you got it wrong, and you're like, wait, did I put it in the wrong format? Just do another problem in the right format and you get your point back. Because remember how it works here is for each type of problem that you're doing, you get this score. And as you get the problems right, it gives you points. And then once you have enough points, it says, okay, you know how to do that type of problem. Let's move on to the next type of problem. So really what you have to do is sometimes you'll get a problem wrong because you're like, like I did a minute ago, like this, where I'm like, I don't know what the answer is to this one. But you just put in an answer and it goes wrong. Just start putting it in the right format in order to make it work the correct way, right? Like I think there was another question in this class, I think, because I was going to show you. So this is a great time to bring that up. Where was it? I think compound inequalities. I think it was this one. See how they have the or, the infinity sign, and the real numbers? Those are there because you're occasionally going to have to use those. So a student was working on these and was getting the right answer from doing these, but then just putting them down here as a list instead of putting the or in between. So here, I'll get this one wrong on purpose. so that we can see what they want. And if you're ever not sure how you're supposed to format your answer, look at the solutions that they give you. You get solutions to all these problems. Look at it and go, I wonder if I'm doing this wrong. And by all means, if you can't figure out the right way to format your problem, send me an email and I can go, oh, I think I know what you're doing wrong. I've already helped a couple students with formatting already. So, you come down here, you get to this point and you have this, but notice how there's an and in between. That and is important for how you do the problem. In this case, it simplifies to x less than or equal less than -8, but you'll notice that and. Let's do one with an or. Let's see one that has an or in it. Maybe that's here. Yeah, here we have an or. So if you solve each of these and then just put the number in as a list, that's not right. You're supposed to put the or in between. And or and, a lot of people take those words for granted, both in the English language and then also in mathematics. And or are actually logical connectives. So if you take a philosophy course, the first chapter that you're going to take, if it's an intro to philosophy course, the first chapter you're going to cover is logic, formal logic. We use the same thing in mathematics. There's slight little differences in how we write things with philosophy and mathematics, but the foundation of both philosophy and mathematics is logic, and the fundamental basis of logic uses the words and or. I think, people use those words all the time and they have no idea the power of those words and or. Those of you who have ever learned a computer programming language, right? You have some understanding of and or are like super powerful words in programming languages. It's the same thing in mathematics. That and or gives us a fundamental logic that everything comes from. So if you get two answers here and you just write them, it's not clear if you think an and or an or goes there. So you need to remember to put that piece in. So if you keep missing these compound inequalities, most people get compound inequalities pretty good. It's probably because you're using the connective wrong. You need to put an and or an or in that statement and sort of do it correctly. And then down here on the number line, click and drag to plot the line. So if we want to go, okay, right here, I'm going to, see how I can click it. And then if you click, now it says click the closed circle to change to an open circle. So if you want it to be an open circle, you just click the thing and it either becomes open or closed depending on what answer you want. And generally, if you're deciding, again, you look at, is it a less than or equal to, or is it just strictly a less than? If there's no or equal to part, then it is probably an open circle. If it is an or equal to, then it is probably a solid circle. So that can help you kind of remember the two there. Okay. Let's see, we talked about this one, right? Yeah, we got that one. We graphed that. Okay. Did we do this one? Oh, yeah. So this one, you might need a calculator. They want you to actually round to the nearest thousandth. You're probably not going to do that calculation by hand, nor should you. I mean, you should probably know how to do it, but the reality is you give this to 100 people, and, 100 of them are going to use a calculator probably to do that. So all this means, again, you take the -2, you plug it in here for x, you simplify everything using order of operations, then they want you to put it in a calculator. So remember how it works in a number. We use a base 10 number system. So every time you move over one place in the number system, that is a power of 10. So at the decimal, you move over to the right, that's 1/10. Over again, 100th, 1,000th, 10, 100, 1,000th. So what, 3 decimal places? Okay, so just keep that in mind. So read that. Sometimes I'll have students that are telling me, like, I know I'm doing the right answer, but it keeps telling me I'm wrong. And they're maybe rounding to the 100th place when you're supposed to be rounding to the 1,000th. So make sure you read carefully. I noticed that that's a big thing with students sometimes to struggle with the homework, is they're not actually reading what's on the screen. So make sure you're reading that, and don't forget about the watch help videos. Those are very helpful, right? I've seen some students that, like, we're months and months into the semester And then like at the beginning of class, I'll hear a conversation where someone's like, oh, well, I got that because I watched the video. And someone's like, what video? You know, the videos that come with the problems. There's videos with the problems? Yeah, so make sure, and I know I get it. I'm not making fun of people. We are trained when we look at websites to ignore ads and ignore fine print and all this kind of stuff. So it's easy to miss it, but it's important that you train yourself to look for those things because they can be really helpful to you, right? Okay, so here's a good question. If there's a problem you're stuck on and choose to see the solution, will that affect the homework grade? I know it states it will be equal to answering the problem incorrectly. Yeah, right. So all that means is you're going to have to do another problem to get that point back. So basically, like, let me show you how this works. So for each of these, you can see, like, the default for a topic, when I pick a type of problem, the default is it's going to make you do 5 of those. But remember, like, up here, I can't remember which class I was talking to about this, but up here, I picked so many different types of problems for this, like, pre-algebra review that I'm only making you do 1 of each type. So of each of these types of problems, you only have to do 1, and it bumps you to the next type of problem. Well, you get those points by getting problems right, and when you get one wrong, it takes 1 away from your score. So you go back down, right? So up here, it's easy. If you get one of these problems right, it just bumps you to the next one. Well, down here, what will happen, say you're doing evaluate functions, and like my score is 1. If I get this right and say this is 7, submit my answer. See how now my score is 2? Well, once my score gets up to 5, it says, okay, you know how to do these. We're going to move you to the next type of problem. So if you mess up by answering one wrong because either you get it wrong or because you didn't know the right format to answer the question, you just lose the 1 point. So all you have to do to get that point back is get a problem right, and then you'll go right back up where you were. So worst case scenario, you end up doing 1 extra problem. And then it's not really an issue. So don't sweat it. If you get one wrong, it's okay to experiment a little bit. And when you're trying to figure out, like, I wonder if this is the right way to format this problem, those points are not lost to you. All you have to do is do a couple extra problems, and you'll get those points back. That's why many students on the Delta Math, if they put in the effort, get 100% on all the homeworks because the points are never, like, gone. And I know it is that way on certain homework platforms. Sometimes there's certain problems where you can keep trying to get your points, and then there's some where they lock you out. Like, those aren't great. That sometimes if it's a multiple choice problem, well, then all you have to do is answer the problem 4 times and you'll eventually get the problem right? But multiple choice are not great math problems anyways. So, right, good question. Let's see. Yeah, and so someone's pointing out this is a good thing worth noting. I've also noticed that when I rewrite the problem to solve it and I get it wrong, it's usually because I wrote it down incorrectly. Yeah, I would say when I'm in class helping students, that's probably half the time. When we're working in class and someone calls me over and they're like, I swear I'm doing what you told me to do, but I keep getting the wrong answer. And then we look, and they wrote the problem down wrong. So technically, they're doing a different problem than they're supposed to be doing. They're doing the problem correct. They're just doing the wrong problem because they changed it. They accidentally changed it into a different problem. I make this mistake from time to time because, I'm doing stuff and I'm trying to talk and I'm trying to think about what I'm explaining at the same time that I'm doing the problem. It's really easy to mix it up early on. But I would say that's probably the first thing you should check. If you get a problem wrong, first thing you should check, did I write it down correctly? And I would, a significant portion of the time, that's going to be the issue. And this kind of will teach you, it's this whole idea, go slow to go fast, sort of Eastern philosophy idea, go slow to go fast. It also will train you when you're writing the problem down, go a little bit slower, double check that it's the right thing. That is what I've learned to do. When I write a problem down, it only takes a fraction of a second, but I just look back really quick. Did I do that right? And sometimes for longer problems, I definitely will check. You'll see me doing this throughout the semester. When I'm flipping tabs I look at a problem here, and then I flip over here to write it down. Oftentimes, you're going to see me go back and go, did I write that down right? Yeah? Okay, good. Because what I don't want to do is spend 5 minutes doing a problem, do it correctly, and then go back and realize I did the wrong problem because I wrote it down wrong. So yeah, that's a really good point that I see hold students back. again, you go in a math class, go slow to go fast. It's better, be the turtle and not the hare, right? I don't know if they do. Do children still learn that story with the tortoise and the hare, where that's what it is, the tortoise and the hare, where you go slow and you actually end up faster because you're consistent and you're not making mistakes. Making mistakes is a huge time sink because you have to go back and figure out where your mistake was. You have to do everything again. It's a lot faster actually to move slowly and make less mistakes. You'll finish faster, and also you won't be wrong as often. So it's really helpful. But it's always going to happen anyways. Just you can reduce how often it happens. I'm saying I have a PhD in math, and I sometimes write the problem down incorrectly. It's just you can reduce the number of times that happens. Okay, let's see. Where are we? What should we cover with our time that's left? Oh, here's some big ones. Profit functions. So okay, revenue for a business as a function of units produced X is shown below by R of X. C of X represents the cost of producing X units. Calculate the profit function and then determine how many units must be produced for the business to make a profit of $957. Okay, that's a lot that's new, and if you're not particularly familiar with business, this can be confusing. Revenue, cost, and profit are actually very simple ideas, but if you've never sat down and actually looked at them, then you wouldn't understand it, right? So I'm just going to explain this problem so that you can do them on your homework. In a business, revenue is the money that's coming in. The money that you get when you sell, whatever. You sell somebody a smoothie and they hand you some money and that money goes in the cash register. That's revenue. Cost is the money that goes out. That's what you pay in bills and labor and insurance and rent and all sorts of stuff for your business. That's cost, right? Parts, whatever it is, if it's ingredients for your smoothie, that costs you money. And then when people buy it, they give you money, and that's revenue. What is X? In this case, they're telling you X is the number of units produced. So let's see. In this problem, they didn't pick something, right? It's just anything. So, whatever it is. Maybe this is phone cases, okay? So this is telling you the revenue is 13X. That would probably lead us to believe that we're selling each phone case for $13. So 13 times X, which is the number of cases we sell. So X is the number of cases sold, $13 a piece. Our revenue is 13X. The simplest way to think about this is the lemonade stand. You're selling lemonade, $2 a piece. To figure out your revenue, you take the number of lemonades you sold, you multiply it by 2, you have your revenue, right? Cost is what we had to pay. And cost generally has two pieces. You'll hear this in business. They talk about fixed cost. The 407 is a fixed number. It doesn't vary. And your variable cost, 2X, does vary depending on what X is. Usually your fixed costs are things like rent, insurance, stuff like that. 2X, that may be what you pay per unit. So maybe it costs us $2 to make a smoothie, or maybe it costs us $2 to make the phone case. Okay, so for each phone case we make, that's $2 that we had to spend, and maybe the 407 was to buy the machinery to make these phone cases. So our cost is $407 plus $2 for every phone case that we sell. Okay, so there's your cost function, there's your revenue function. What is profit? Profit is the revenue, the money in the cash register, minus the cost, the money that you have to pay bills with. Whatever's left over, that's your profit. So you just take this value minus this value. So 13X minus 2X plus 407. So let's see if I can, it's not going to let me copy that. Let's see. So let's look at this. R of X is what? 13X? Is that what it was? And then was it 2X plus 407? Is that what it was? Let's see. So see how I'm switching back to double check. 2x plus 407, 13x. Okay, so we got those right. So my profit function, equals my revenue function minus my cost function, right? It's the money in the cash register minus the money that I owe people for bills. That's my profit. That's what I get to keep at the end of the day. So in this case, that's 13x minus 2x plus 407. Now notice, I'm going to write a wrong version of this so that you don't make that mistake. Notice that I didn't write it this way. See the second way? This one's wrong. Why is that wrong? Why is it right to put parentheses around this and not here? Well, I'm supposed to subtract my cost function, right? And the 407 is part of, oh, I'm not on the screen. You can always let me know if I'm not on screen because it doesn't help if you guys can't see what I'm looking at. So here's the right version. This one right here is the correct version. The one below it is the incorrect version. So why is this one right with the subtraction of the parentheses and not this one? Well, I'm supposed to subtract the cost function, and the 407 is part of that subtraction. It's part of the cost function. But notice down here, I'm not subtracting 407. Up here in the parentheses, I'm subtracting everything in the parentheses, including the 407. So if you don't put these parentheses in here, you'll end up with the wrong function. You won't subtract the part that you're supposed to. So that parentheses is actually really important because then this becomes P of x is equal to, so 13x minus 2x gives us 11x, and then we distribute that negative in, remember distributing the negative, to give us minus 407. So 11x minus 407. Okay, so that's our profit function. But what were we asked? Like, this is very common. I don't know. We've been talking so much, I forgot what the question is. Let's go back and read it again. I suggest that you read I suggest that you read the question probably numerous times by the time you're done. So let's see. What do they want to know? Calculate the profit function. Check. We think we did that correctly. And then determine how many units must be produced for the business to make a profit of $957. Okay, they're telling us the profit should be $957. And profit is equal to 11x minus 407. So we want to know when that profit is equal to, was it 957? 957. So I'm literally going to set our profit function equal to 957. And then we're going to solve that problem, right? So now we solve that to get, let's see, 11x equals, okay, so if we subtract, so the 7 puts us at 950, minus 4 puts us, I think, 550. So 11x equals 550. Divide by 11, looks like x equals 55. That's a good sign that we got an integer. Many problems that you do make sense with fractions, but in this case it probably doesn't because they're asking how many units must be produced for the business to make a profit of $957. We probably don't make a profit when we create half, if we're creating car stereos, we probably don't make money for making half a car stereo, right? So the fact that it came out as an integer is a good sign. Some problems are going to come out fractional, and that's okay. Doesn't mean they're wrong. I have students call me over and say, oh, I keep getting this problem wrong. And I go, why do you think it's wrong? Oh, because I'm getting a fraction is the answer. Sometimes fractions are perfectly legitimate. So let's see, 55, submit my answer. Uh-oh, that is not correct. What did I do wrong here? Let's go back and look. 11x minus 407 equals 957. Yeah. Not in this case. We're supposed to subtract 407 because we're adding the 407 in the cost function, but we're subtracting the cost. So if you think about it, the amount of money that we here we're supposed to add 407. Yeah, thanks. So here we should be. Wait, that's not going to come out right though, is it? So 11x minus 407 is my profit. This equals 9. Oh, yeah, thanks. If the profit, you're right. If the profit is 957, right, I'm supposed to add here. I'm trying to talk while I'm doing the problem. So right, we should add this. So, but that is going to come out weird maybe. Let's see. Let me double check this. So if we go 957 plus 407 equals 1,364 divided by 11, 124. Okay, yep, thanks. That was it. I was supposed to add here. So this should be 1364. And then when I divide by 11, I'm getting 124. Okay, does that make sense? Let's see. Let me double check this work before I only get one more chance to get it right. So let's see. Does this make sense? So 11x minus 407. So we got 11x minus 407. Add that to both sides. Divide by 11. Okay, so I think that's right now. So let's see. 124. Okay, good. Got it right there. So, and then they go through and explain it. So it's, and notice how it looks like what I did. They've got the parentheses. They've got the, the different pieces. We solve it. We get x equals 124. So it can be very helpful to watch those solutions. Okay, so that's the profit stuff. Those problems are more or less going to work like that each time. So just understand revenue cost. It's just a chance for you to do some word problems and put this stuff into play. Oops, did I just close Delta Math? Didn't mean to. Let's see. Let's go in here. Delta Math. Where were we? Yeah, thanks by the way for the help with the problem there. Where was the other thing? Oh, write and interpret functions. This is one that frustrates people. And I think the reason why this is frustrating is because you can't memorize it. You have to critically think. Critically thinking is hard, right? As a society, as a culture, we're not great at critical thinking. We're sort of, and we're getting worse at it all the time. It takes effort. It takes work to critically think through things. Sometimes it makes you decide on things that you don't like, right? That's how science works. You might really like a certain thing about science, and when new science comes out, you have to abandon those old ideas. You have to take the ideas you're comfortable with and say, well, it looks like this new science is a little bit better, right? And critical thinking is hard. You just get better at it by doing it. There's no magic rule I can give you that, well, in this case, you always do this, because that's the whole thing. Is like, it wouldn't be critically thinking then. It would just be memorizing, right? So it's not easy to do. So let's work through a little bit of these with our time left to kind of make sense of this, because I know some people are going to struggle a little bit with this. So what do you do? First thing, read the problem. And sometimes people just read it straight through and go, okay, I read it. It's not really enough to read it. It's enough to understand it. Do you understand the problem? Like, could you explain it to me? Could you summarize to me what's going on in the problem? If the answer is no, then you didn't do a good enough job reading it. You might have to read it again. So let's see. Nathan makes $12 per hour when he babysits for his younger siblings. Answer the questions below regarding the relationship between the hours spent babysitting and the total money earned. So we're going to be writing a function here, it looks like, based on some variables that we need to define. These are steps that I see people miss all the time. They're trying to write equations because they're like trying to get through the problem, and they're like, oh, I'm trying to write this equation, but I don't know how to write the equation. You go, okay, what are your variables? I don't know. Well, it's like trying to build a house before the frame, the wood for the frame has arrived. You don't have the pieces in place to build the frame. How are you going to start building the house, right? So you have to have your variables defined before you can build your equation, because the equation involves variables. How are you going to do that if you don't even know what your variables are? So that's why they're making you go through here and decide what the variables are, and then you create your function from here. So let's see. The independent variable x represents the... Nathan makes $12 per hour when he babysits for his younger siblings. So let's see, what are our options? Amount of money earned or number of hours babysitting? Well, I would think that it makes more sense to have the x variable be the number of hours babysitting, right? You can kind of think of a function as a question and answer. What are you more likely to ask? Like if you're sitting there and you just babysat for 4 hours, you're probably going to go, okay, I'm taking 4 hours and I'm going to figure out how much money I made, right? So then that means that your x would be your number of hours. That's kind of the thing that you know, and you want to figure out the other thing. The dependent variable, what depends on the number of babysitting hours? Well, that's the number of money, the amount of money earned. Once you've decided how many hours you've worked, that indicates how much money you are going to have, because the amount of money earned depends on the number of hours babysitting. Okay, does that make sense? The independent variable x represents the number of hours babysitting, and the dependent variable is the amount of money earned, because the amount of money earned depends on the number of hours babysitting. Right. You could argue it the other way around and say, well, couldn't I figure out how much money I want to make and then determine the number of hours babysitting? Yeah, but that's a little less natural way of thinking about it. You can do certain problems that way, but you have to sort of make sure that you realize you're doing it in a non-standard way. Okay, a function relating these variables is, okay, how can I relate these two variables? So if x is our input, then, well, we want to figure out the amount of money earned, earning $12 per hour. So for each hour worked, who is this? Nathan makes $12. So 12x. That's what what's his name? Nathan makes 12x. For each hour earned, makes $12. So z of 3 equals 36, because that's 12 times 3, meaning 3 hours of babysitting will get $36 in earnings. See how the only way to get through a problem like this, you're not going to memorize anything. The only way to get through it is to critically think your way through the problem and try to understand, what are we talking about here? And the only way you can do that is by understanding your variables. I actually think these are excellent problems because it forces students to do the thing they like to skip, which is understand the variables. How could you possibly write an equation if you don't know what the variables represent? It doesn't make any sense, right? But it's a step that students really like to skip. Let's see. All right, I got it. Got it right. That's right. And then they kind of go through and they give you all of the stuff here. And let's see. And the problems are pretty much going to be like that. So you're going to go through. We've got a different number here. Here it's babysitting. I don't remember if they have other ones that are non-babysitting ones. I'd have to remember. But that's how those problems are going to work. Okay. So try to make sure you get some homework done. Those of you who have done some homework, keep up the good work. Keep getting more homework done. Those of you who have done no homework, make sure you get some homework done. If I go on Thursday and I see 0 work done or very little work done, then my hands are kind of tied. I gotta drop you, right? And I'm not looking to drop anybody, but it's, contractual. Got to do it. So I've got my role taken. We got all that taken care of. Make sure that you've done some assignments by Thursday. Those of you who want to stay, in good standing in the class. Do lots of homework if you can. Remember the help videos right here. Let's see, let's go back to here. So work through these. Remember, I kind of moved rational expressions and rational equations to later, so you get a little bit more of a due date on that. When we have tests or quizzes, will we be able to use calculators? If so, will we have to bring our own? Yeah, so that's a good question about calculators. We used to have a system where we rented out calculators at the school. You could just get it free for the semester. But because of COVID, they kind of don't want to do that anymore, so we don't really have the calculators available to you. Most of your quizzes, you will not, at least for now, need a calculator. I may down the road. Like I say, I haven't done the second half of this class before, so it kind of depends how a lot of those problems come out. It may be the case that I sometimes let you use a calculator and sometimes do not. I tend to try to like to write quizzes where you don't need a calculator, where if you know your basic algebra, you can get through the problem, right? I find that's preferable. Calculators cause some issues for a lot of reasons. In some classes, they're very appropriate. In a statistics class, it's very appropriate to have a calculator. There may be appropriate times to have calculators in this class. I don't think you're going to need anything fancy. I don't think you need to go out and buy a $100 calculator or anything like that. For $5 to $10, you can get yourself a nice scientific calculator. But I would also say wait for now, and we'll kind of see how it goes. I probably, like I say, I usually try to write my quizzes where you don't need a calculator to do it. And for tests, we'll have to see. We'll kind of see where it comes out. A lot of times, believe it or not, the calculator is sort of like a psychological impedance for students. They somehow think that the calculator is really smart and that they should just trust what's in the calculator. So I see a lot of times students will do a calculation and they'll hit a wrong button on accident and not realize it, and they get an answer that's totally absurd, but they just trust it. Well, it's what the calculator says, and calculators don't make mistakes, which they do, by the way. But and then they just kind of trust it, blind trust in a calculator. Those of you who get into like calculus and stuff, if you're going that route, you'll see there are mistakes that a calculator can make. Like a TI-84 will sometimes, anything that uses what's called a floating point operation, mistakes can happen even in a computer because there's a small rounding error that occurs. But bottom line is I try to write stuff so that you don't need it. There's probably not going to be a lot of quizzes in general. Kind of depends how this class goes. I might have to make some changes since it's my first time teaching this particular class. So probably not too many quizzes, but there will be a test in the middle of the semester and a test at the end. I don't think I'll say this. You will not have a calculator on the first exam. I may end up allowing you a calculator on the second exam depending on how that second half of the semester goes, and it's not depending on you as students. It's depending on just what happens. I'll know a lot more about the material in this class when we get to the end of the semester than I do now. I've kind of looked it over and I know the type of stuff we're going to be doing, but I haven't actually done it all, so I'll know more then. So you definitely will not have a calculator on the first exam. You may be on the second. It depends. So no guarantees. Okay. So that's where we're at for now. So I'm going to shut down the YouTube stream. Anyone who wants to ask me questions or talk to me or share a concern or, anything that's making you uneasy in the class, feel free to talk to me in Zoom. I'll stick around as long as people want to talk to me. Otherwise, good work. I'll see you in a week, and keep working on the homework. All right. Thanks, everybody. Thank you. Hey, I had a question. Okay. Give me one.